Alrighty guys, so today we are going to be doing a quick little shindig on this video about absolute entropy. Okay, and this is going to be like a little bit of a recall back to enthalpy as well, because absolute entropy is the same, like the process to find absolute entropy is the same process we use to find the absolute enthalpy. Okay, so the enthalpy of formation for a reaction, we did the delta H for the reaction is equal to the sum of the delta H of formation for the products minus the sum of the enthalpy of formation of the reactants. Now, believe it or not, whether we're talking about absolute entropy or absolute Gibbs free energy, the calculation is the same. Okay, so for the absolute entropy, we get the sum of the entropy of formation for the products minus the sum of the entropy formation for the reactants. Okay, that will give us the absolute entropy. Now that absolute entropy would be for a specific, element, molecule, anything like that. Okay, so we want to look at, once we find this number, that's what I wanted to say, once we find this number, we can plug it into our delta G equation, so our Gibbs free energy equation. Okay, this one is going to be an important one to remember, delta G naught. Remember that naught is standard temp, pressure, if I could spell pressure, and 1 mole. Okay, that's what that circle, that knot, those circles, that's what they mean. It's at standard temperature, pressure, and 1 mole. Okay, so the delta G naught for a reaction would be the delta H naught for that reaction minus the temperature that reaction is happening at times the delta S naught. Okay, so if we want to find the absolute entropy, we have to have a table of the entropies of all of our products and reactants. Okay, we take the entropy of all the products added together minus the entropy of all the reactants added together, and we get the entropy for the reaction itself. Okay, now as a reminder, this is going to be a very quick video because this is a very easy little calculation. As a reminder, delta G naught, if it is below 0, the event is spontaneous. Now that spontaneous means it will happen without any push. Okay, it doesn't matter, it doesn't mean it would happen fast, it doesn't mean that it will happen like super quickly, like when we're talking about kinetics. What it does mean is that it will happen on its own. So rusting iron, okay, that is a spontaneous process. Okay, it will continue to happen on its own. However, that is not a very fast process. Okay, it is not fast. When we look at like iron gates that are rusted, we say, wow, those are old. We don't say, oh, those look brand new, they must be out, they must have just come off the market. Okay, so just because an event is spontaneous does not mean it is fast. And so the spontaneous event just means that it will happen on its own without any push. Okay? So that is all for this video. It's a very quick one. We'll be getting into some more complex calculations, example problems next one. But you guys needed to know how to find the absolute entropy. Okay, same as finding the enthalpy of a reaction. Okay, all right.